Welcome to All This Math. This is Professor Parker, and today we're going to talk a little bit about the Rational Root Theorem and what it's used for. And we're not going to go too deep into it. We're not going to actually use it to solve an equation or solve a function, but we're just going to talk about how to find the actual rational roots when given a function. All right? So the instructions say to list, as I said, list all the possible rational zeros. Now, zero is just another word for a solution or an intercept. Zero is called a zero because it's the value of x. If you were to graph this, it's the value of x when y is 0. So basically, it's the x-intercept. That's why it's called a zero, right? Because it's the value of x when y is 0, also known as the x-intercept, all right? Or the solution to an equation. And there will be multiple solutions, okay? In these types of equations, because as you can see, the exponents are bigger than 1. All right, so two things you need to be concerned with. You need to know how to factor. You need to know how to find the factors of numbers, right? And you need to be concerned with this number at the end and this coefficient in the front. This constant at the end and this coefficient in the front, okay? Now, this is how you find all the possible rational zeros. You think of all the possible factors of the constant at the end. So plus or minus 2, right? Well, actually, no. Let me rewrite this. You want the factors of positive or negative 2. And then you're going to create a fraction. You're going to divide that by the factors of positive or negative 2 again, because that's your lead coefficient. So basically, you want to memorize this, right? The Rational Roots Theorem says that you can find all of the possible rational zeros or possible solutions by taking all the factors of the constant and dividing that by all the factors of the lead coefficient. All the factors of the constant divided by all the factors of the lead coefficient. So what does that look like? So positive or negative 2. Matter of fact, let me get specific. So 2 is a prime number. So this is kind of easy to do because 2 is a prime number. So we're not going to have a whole lot of choices, right? So positive 2 divided by positive 1. All right, that's one possible zero, right? Because look, positive 2 is one of the factors of positive or negative 2. Positive 1 is one of the factors of positive or negative 2. And then I could do negative 2 over positive 1, right? And then I could do positive 1 over positive 1. And I could do negative 1 over positive 1, right? And then I could do positive 2 over positive 2, but I don't need to do that because that simplifies to 1. And doesn't 1 divided by 1 simplify to 1? Right? So, but what about in my denominator? I have all 1s here so far. I could put 2s here. So what if I did positive 1 over positive 2? Right? If I did negative 1 over positive 2. Right? So let me kind of clean this up and simplify some of these. So basically, my rational roots could be 2, could be negative 2, could be 1, could be negative 1, could be 1/2, and could be negative 1/2. Right? So when you use the rational root theorem, you're kind of like playing a game. It's kind of like playing a game. But you just have to remember this. You have to remember you're taking the factors of the constant term at the end, and you're dividing those by the factors of the lead coefficient in front. The factors of the constant at the end divided by the factors of the lead coefficient in the front. So the factors of positive or negative 2. And again, when we factor something, our factor could be positive or negative, right? So the factors of 2 are not just the positive factors, not just positive 2 and positive 1. The factors of 2 are also negative 2 and negative 1 as well. All right? So these are all the possible rational zeros of this function. because we just used the rational root theorem to come up with. Now for number 2, we're going to have more choices. And how do I know that? Because 27 or negative 27 is a composite number, unlike 2, which is prime. So we got a lot more choices. So again, we're going to do the same thing we did right here, right? We're going to say the factors of divided by, or the factors of positive or negative 27 divided by the factors of positive or negative 2. All right? So if I start with the biggest factor of 27, I could say, you know what, I'm going to do plus or minus. Plus or minus 27 over 2, right? And then I'm going to do plus or minus 27 over 1, right? And then I'm going to take another factor of 27. Another factor of 27. I know 9 times 3 is 27. So then I'm going to use plus or minus 9 over 2. And I'm going to use plus or minus 9 over 1. And I also know that 3 is a factor of 27. Right? So plus or minus 3 over 2. And plus or minus 3 over 1. Also, don't forget, 1 is a factor of 27. Just like 1 was a factor of 2. So we have 1s in our numerators. Plus or minus 1 over 2. And plus or minus 1 over 1. So now from there, I'm basically looking at, let me kind of simplify this. Plus or minus 27 over 2. Plus or minus 27, because 27 divided by 1 is just 27. And then I got plus or minus 9 halves. This is just going to be plus or minus 9. This is going to be plus or minus 3 halves. This is going to be plus or minus 3. This is plus or minus 1 half. And this is plus or minus 1. So how many possible rational zeros is that for this one? We got, because there's a positive and a negative version of this fraction, 27 over 2. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 possibilities. 16 possibilities in this particular function, right? 16 possibilities in this particular function. All right. But like I said, what we would do if we were trying to actually solve, we would then use synthetic division. We would just kind of test these out. We would just test these out. We would pick different ones and use synthetic division. And when we use synthetic division, whatever zero would give us a remainder of 0, we know that that is one of the zeros, right? Because I think that's part of, I have to check my notes on this, but that's, I believe, part of the remainder theorem, right? The remainder theorem. So that's how we would use the rational roots theorem. But for now, I just want to show you how to find the possible rational zeros. We're not going to get into the remainder theorem and synthetic division right now, okay? All right, so thank you for tuning in. If you learned something, like the video, share the video, subscribe to the page if you haven't already. All this math. All right? See you soon on the next video.